Okay, welcome. This is Writing Game Servers with Elixir. So I am Eric Oestrich. I am an engineering manager at SmartLogic. SmartLogic, we build custom web and mobile applications. We used to be in Baltimore, or used to be based in Baltimore, and we've built over 150 apps since 2005. So let's take a look at the agenda. So we're going to see why would we want to write a MUD game server, and then what are Xventure and Kalevala, my two projects. We're going to take a deeper look at Kalevala, and then see what Elixir brings to the table, and then a quick look at a demo. So first off, why MUDs? MUDs are games for programmers. There's no graphics at all in them, generally speaking, and anyone can write text. You don't need to be an artist or a 3D modeler to make these games. So this is what it looks like. So it's just a bunch of text. The most you get is some ASCII graphics with this map here, and some coloring. So first off, what is Xventure? So this was my first foray into OTP. It was a learning playground. So not everything was the most well laid out for what is a good Elixir application. And it's kind of like functional programming written in an object-oriented style. So things could be a lot better. So now what is Kalevala? It's an ancient Finnish text, but for our purposes, it's a world builder toolkit. You can think of it as Xventure 3.0. It's a rewrite of a lot of the internals of Xventure that I'm not entirely happy with. And this is the third iteration because there was a second step that kind of wasn't the best laid out as well. So I restarted again. So the pieces of Kalevala. We're not going to look at everything that make up Kalevala. We're just going to look at the things that are different. And real quick, these are my cats. So this is Worf, Kern, and Odo. And we'll be seeing them throughout the presentation. So first up, commands, controllers, and actions. So these are the input and event processing for the system. So this is a series of callbacks that the modules can hook into, and it just breaks up functionality into smaller pieces. And then the biggest to smallest is controllers, then commands, then actions. So let's take a look at what we had before in Xventure. So here's what Xventure looks like. We can see, so it had some run. Everything was just kind of in the same file. It wasn't the best laid out. This is like everything that a say command can do. So say is you type say, and then it gets output into the room. And we're going to be looking at this command throughout the presentation. So in Kalevala, this is the framework. Sorry, this is the using Kalevala. We have a controller here. This is the command controller. So your text comes in, it gets sent to this receive function. It gets routed through some commands and then spit out down here. So here's the router. Of course, this is slightly off. So this is what we're supposed to be looking at. So here's the say command. This is how it gets parsed. We can see how it got parsed up above. This was this like hole from like here all the way down to here. It's not the nicest. I've recently switched this out. This is Nimble Parsec if you've never seen that before. This is we're still in the usage of Kalevala in the example app. So this is the say command. So this is it broadcasting out. The router calls this function, and then this calls a action. So actions are just the smallest form of a thing that will happen in the system. We'll see why later on. Yeah, so this is, I think it's a lot better broken up and not just a big blob. So this is better. Modules are broken up. The session process delegates a lot of things now, which is just better so that the gen server isn't overloaded with things in the module itself. This is Worf again. So now we're going to take a look at the con. So this is a struct similar to a Phoenix con. These are character internals, or sorry, the character internals build up intents that it wants the foreman process, which is the session process for a character, to play out in the world. So if we take a look at this, previously Xventure had no concept of this. Now this is kind of what they all look like. So we make a new construct every time a new event or text comes in, and then we pass it off to the controller. So this is the higher up step from what we saw before. Now we're in the framework. So it says, here, go do this thing, and then we handle it down below right here. So we send out into the world. And here's kind of a little diagram of what's happening. So the player sends input into the foreman process. The foreman runs that through controllers, commands, and actions. We build up what wants to happen, and then the foreman blasts it out inside the game and then back to the player for text and events that's happened. So this is better because the core stays functional. So if you've seen Gary Bernhardt's talk Boundaries, this is kind of an implementation of that. Definitely recommend watching that if you haven't seen it. So the internal commands do not interact with the world, so it stays functional, will always be the same when you call it. And then once you hit the upper levels of where the foreign process is, that's when it then goes and interacts with the world. So next up we have events. This is Worf again. He's outside at our old apartment. So events are the atom of Kalevala. Everything is an event. An event is just a generic struct with a set of specific payloads. And then the pub sub for this are the rooms, which are just, yeah. Okay, so before and after. So this one's where we get kind of messy in Xventure. So we're looking at Xventure here. So this is how I had started converting some of the event system in Xventure from a tuple set. So pretty much everything in Xventure is this tuple. So you can see down here, it's a set of tuples that are like tagged. And it's kind of messy. Like you have no idea how long these tuples are, how many elements are in it or whatever. So I was like, this Xventure was like midway through this, but I still wasn't happy. So if we look at what's actually going on here, this eventually calls down to here. So here's our notify function. So it's just pattern matching on like the struct. Yeah, I still wasn't. This is kind of weird. I'm not super sold on how this is. So if we look at what Kalevala does, so that we're in the framework here. So here's a new event comes in, it gets passed to the controller. The controller, sorry. So now we're in the example app. So we have a command router. So when someone says something, we're getting blasted a message topic, which then triggers on this echo, which then calls this function here. So we can see here, the con assigns a bunch of stuff, renders, and then prints out. So I think this is just a lot better. And all of them have this data key here. So it's a topic and a data. And so it's just a lot more well known as to what's happening instead of these tuples of undetermined length. Yeah, so this is kind of the same thing. Events just pipe a con through data transformation, and they don't directly affect the world. So next up is views. This is Odo. So these are very similar to Phoenix views. It's just a module with a bunch of render functions. And the very important thing is it builds up IO data lists, which we'll see. So IO data lists, if you haven't seen them, are just a list of strings or other lists of strings that can kind of be infinitely nested. And Erlang is just very fast at dealing with these. And then the other thing that changed here, so we have views, and then we also have an output processing system. So this transforms the data like as it's going out to players, and text is reduced over. So these IO data lists are reduced over processors. So first up, we'll take a look at how Xventure dealt with views, quote unquote. So this is where like it has a bunch of like format modules that you call direct functions, and then they echo directly to the socket. And so here you can see what this looks like. I had like started getting towards like a template assigning thing, but it was like part way worked through, and yeah, it was a kind of a half mid step. And then so the main reason that this is bad is there's a lot of these socket echoes. If you look through here, that's just kind of like littered throughout these command modules. It's really hard to find out where these texts like hang out, and you can sort of think of this as like if you're doing a PHP app where like all of a sudden you're inside of a module and then you just like close PHP and now you're writing HTML and then you open it again. And so like that's kind of what's happening, and like that's definitely gross PHP, and then this is not the best as well for spitting out text. So now if we look at, this is the example app. So here's our echo again. So we're assigning stuff and then we're calling render. You can call multiple renders because of how this all works. And then there's a prompt is a similar thing, but it just doesn't add a new line. And then here we can take a look at the save view down here. So here's this is sending out an IO list, right? So it's a list of strings. So you can say, you say, we have some things, first the say command that you can do, and then render out text here. And this is a custom macro that spits out IO lists. So you can see here, and these also bundle events together. So this is an event that has text tagged with it. So the front end can decide, do I want to act on the event or display the text or do both? And it's been a nice change. So now let's take a look at the output processing. So this Xventure like wasn't the greatest either so I had started on something called, I was calling VML, so the venture markup language. This was a set of, this is what is this? This is Lec, I think the Elixir. So it parsed through this. Here's the Yek side of it. So this is the grammar, and then there's a Elixir module that deals with this and kind of parses through it and all that. The biggest issue with this is that this was not set up from the beginning. So everything in Xventure that deals with VML like converts it into a like struct of VML and then like collapses it back down to a string here, because nothing could deal with that side of it. So it kind of like pulled it into an AST and then collapsed it back and then pulled it in and collapsed it back. And so there's just a lot of duplicate dealing with that. And the usage of VML was kind of very scattered throughout everything. So now if we look at what Kalevala does, this is the framework. We're just going to look at a single like output processor here. So there's a few set of callbacks. So you get an init if you need to build up some context. There's a post parse, and then the important thing is this parse. So here, this module is acting as a VML parser. So it just recursively looks at each of the IO strings and kind of walks through them. So it's trying to find like the opening tags, the closing tags, and all of this, and then kind of building up a tag structure as it goes. And then further on ones work on this. So we can see open tag, ignore it because we're stripping tags. close tag, ignore it. Otherwise, just like append it to the data list. Here's dealing with colors, etc. And we'll see this more in the demo of how these processors work. So this is a lot better because the commands render views instead of just echoing directly. Kind of goes back to everything else about the con where it just builds up an intent and then something else deals with it. IO data lists are extremely fast compared to building real like full strings. In the second iteration I had of Xventure internals, this was last year at ElixirConf. I just saw Joanna Larson's string processing talk and was inspired to start messing around with IO lists for that project. And as part of this, I wrote a Benchy test, and it was actually the IO list side of the test was so fast that I actually found a bug in Benchy on Mac because of it was just considering it as 0 seconds. Like that's how fast this was. And the other important thing is that you can change the list of processors. So you can reorder it, you can change it, and we'll see the power of this in the demo. So next up, we have character brains. This is Odo. So character brains use behavior trees. A behavior tree is a mathematical model of plan of execution used in video games. And I see the question just came in and we're about to answer that. So behavior trees for us, we can consider it as a simple AI. It's a tree with branches and leaves. Branches are selectors and leaves are evaluated to influence the selector. So before we see what one looks like in Kalevala, before in Xventure, there was like also a mid-step rewrite. The first system I had was, it wasn't the best either. I rewrote it to something I was more happy with that was a lot more generic, but not a behavior tree. And so for Kalevala, I went with something that is like a known system, and instead of something I made up. So here's what one looks like. So we have a brain called a generic hello. So the first, and which is has a single node, which is a conditional selector because it has nodes. So then this node has a child that is a message match. So this, the conditional selector, the way this works is it will keep running its children in order as long as the subnodes are passing. So for this, if someone says hi to this character with this brain, the condition here will match, will still be true. Then we'll start to evaluate the sequence. Sequences always run all of their nodes in order, regardless of if they pass or not. So then if this one matches, we'll then go ahead and evaluate the sequence, which then says, hello, Eric, how are you? And here we can see that these are saying, the reason we want actions is because these brains can use them directly, and they're like as small as reasonably useful, I guess. So this is just a way to publish a bunch of messages, and you can make so this is how this works. So an incoming event comes to the foreman. Instead of dealing with events through a command router, an event router, it gets passed through the brain. So the event comes in, the brain evaluates its tree to see what actions it wants to do. It generates those actions into the con, sends it back up to the foreman, and then those get blasted out as similar for everything else. So this is better because nodes are just data. It's actually built with protocols, so each node is a struct. All the selectors are structs. All of the conditionals and other leaves are just structs. And so the tree just kind of reduces through it and says node.run, and it'll try and run on the conditional struct, which then runs its own implementation of the node protocol and acts as however it should. So finally, the world. This is actually, we'll be skipping it because I gave a talk about this at the Big Elixir 2019 for all aboard the Stateful train. So if you're interested in how Kalevala and Xventure deals with world state, go ahead and watch that. So what does better Elixir bring to the table? So your functional core, you don't modify the outside world in your internal functions. Again, go see the talk Boundaries by Gary Bernhardt for more on that. We're now, all of these commands, actions, events, all of this does data transformation. So we just take a con and we pipe it through a series of functions that alter that and then gets replayed out. Similarly, like together, going with the last one, you can piece together your functionality through a lot of smaller modules, and you just kind of put glue code to pull these all together, and you can get a bunch of new functionality with just reusing what you have. And the other very key thing is that events are structs with a set of like a topic and a data. So this is really similar to how Phoenix Channels works, instead of tuples, because you have a known set of keys and you don't have to worry about how deep the tuple is. All right, so now for the demo, we'll drag on. This is the example app here. This is the web client that comes with it. So if I go ahead and say, look, we can see this like gray text here, here, all these things. So these are metadata on the tags for like the town square or the character here, the item. So if we go ahead and down to here, we can see the output processor list. So this is the one that deals with that. So if we go and comment that out, restart the server because of where that's located. If we reload this, suddenly all of the IDs are gone. So that's the power of dealing with the output processors. Just based on the list there will influence how this comes out. The other really cool thing, down here, we're actually in a telnet client called Tintin++. So if we go ahead and connect, so this is the same code that the front end is using. So the back end does not know what you're connecting with. The Kalevala handles this. So there's a port listening for telnet. There's a port listening for WebSocket. That's just your normal cowboy plug endpoint. And so down here, this is the same. The game code just renders the same IO lists, and then they get processed differently on the way out. So there's actually a here tag colors. This one converts VML tags into ANSI escape codes. So that's how this works. So there's like some escape bracket 33, whatever green is or whatever M, and then like resets back to your standard color. So I think this is pretty neat that the game internals don't care what that looks like. Okay. You can, and so wrapping up, you can find this on GitHub. It's at Oestrich/Kalevala. And I'm also a co-host on the Elixir Wizards. Check us out at elixirwizards.io. If you're interested in some more cat pictures, I actually made an application that gives you a random picture of our cat Worf, and every hour a random one is tweeted out at war_fee. If you're interested in a sticker pack of my cats and some of the projects I have, I've got about 30 of them, so it's first come, first serve. I'm happy to send some out to you since we can't meet in person. Image credits, and if there's any questions, I'll go ahead and answer them. So okay, all right, thanks.